Assalamu alaikum and very good morning, dear students. Today is the second and last video of this chapter. The chapter is operation on sets, and today's topics are operation on sets, Venn diagrams and properties of sets. Dear students, please open your mathematics books, new countdown, book 7. By the end of this lesson, you should be able to do operations on sets, draw and identify Venn diagrams to represent sets, understand and use properties of sets. Operations on sets. Operation takes place between two sets or sometimes maybe more than two sets. In this lesson, we will learn about basic operations. The first one is union set or union of sets. Second is intersection of sets, and then difference of sets, and then complement of a set. Now, first of all, union of sets. A set containing all the elements of set A and set B is called the union of set A and set B. For example, set A has elements 1, 4, 5, 6 and 9, and set B has elements 2, 4, 6, 7 and 8. And the union of set A and set B is, first we will write A union B, this is sign of union, and we will write set A, which is 1, 4, 5, 6, 9, then union 2, 4, 6, 7 and 8, and we will write all the elements of both the sets, which is A union B. It is 1, 2, 4, 5, 6, 7, 8 and 9. Have you noticed one thing, that 4 is element of set A and 4 is element of set B, but we have written it once. Yes, this is the rule. If both the sets have same element, we have to write it once. Same is with 6. 6 is here and 6 is here, but we have written it once. We can find union of more than two sets. In the same way, if we have 3 sets, we can find its union. Now, intersection of sets. A set containing the common elements of set A and set B is called intersection set of set A and set B. For example, set A is 1, 4, 5, 6, 9, set B is 2, 4, 6, 7, 8. Now, the intersection of set A and set B is, we will write A intersection B. This is the sign of intersection. We read it intersection. Now we will write elements of set A, then sign of intersection, then elements of set B. Then we will find which elements are common. Is 1 common? No. 2 is common? No. 4 is common? Yes, exactly. Very good. And then next digit is 6, which is common. So there are 2 elements, 4 and 6 in A intersection B. We can find intersection of more than 2 sets. The same way, we can find common members of 3 or 4 sets. Now, difference of sets. The difference set of any 2 sets, set A and set B, is the set of the elements of set A which are not in set B. Difference means minus, you know this. So it is same way, but we will do it with sets, the elements. The difference set is expressed as A minus B and is stated as A difference B. For example, set A is 1, 4, 5, 6 and set B is 4, 6. So A minus B is, first we will write elements of set A 1, 4, 5, 6, then minus, then elements of set B 4, 6. Now when we will minus 4 and 6 from 1, 4, 5, 6, the remaining elements are 1 and 5. So it is minus like ordinary minus thing, but we will minus elements here. Now, complement of a set. If a set A is a subset of a given universal set. What is universal set? Yes, you did it in last video, in last lesson. Yes, who can tell me? Yes, exactly. Universal set is a set containing all the elements under consideration. Okay, now what we were talking? Yes, we were talking about complement set. Now it is represented by A and then comma on top of it. So for example, universal set is equals to 1, 2, 3, 4, 5 till 12 it is. It means all the digits which comes in between till 12. Then set A is 1, 3, 5, 7, 9 and 11. Now set A complement is equals to set U or universal set minus set A. Then set A complement is equals to, we will write universal set, then minus, then set A. So whatever we get after minusing or subtracting, these are the elements of set A complement. 2, 4, 6, 8, 10 and 12. Because all the odd numbers were the members of set A. So when we minus it from universal set, we have 2, 4, 6, 8, 10 and 12. So this is set A complement. I hope this is clear to all of you. Now Venn diagram. Yes, you did Venn diagram in your previous year. A Venn diagram is a pictorial representation of a set. Venn diagram for a set, yes, it is over here. Here it is saying set A is equals to set of sports that cannot be played with a ball. It would look like this. Now you will see inside the circle there are the members which are the part of this set. Set A, set of sports that cannot be played with a ball. So it's written badminton, frisbee and swimming. You like to play all these. Okay, then out of this circle all other sports are written which can be played with the ball, like cricket, tennis, football, hockey, squash and basketball. Who likes to play these sports? Oh, everyone. All other sports not in the set lie outside the circle and known as universal set and denoted by U. So all these sports are the part of universal set. And we just showed this set, set A, inside the circle. Now representation of union and intersection sets through Venn diagram. Now we have set A 1, 3, 4, 9 as its elements and set B 1, 2, 3, 5, 6 as its elements. A union B, like set A union set B is equals to 1, 2, 3, 4, 5, 6 and 9. And we will write it in this form. Inside the rectangle, one circle is showing set A and the other circle is showing set B, and we will write common elements in this common area which is part of this circle and part of this circle also. So set A is 1, 3, 4, 9 and set B is 1, 2, 3, 5, 6. 1, 3 is common in both the sets, and because we are doing A union B, so we will shade the whole part which is showing A union B. Now A intersection B, the set we will make in the same way, only the difference is where do we have to shade. We will just shade the common area, the common part of set A or set B. So 1 and 3 are common elements or intersection part or the elements of intersection set, and we will just shade this area. I hope this must be clear. Now, properties of sets. I am writing these three sets and we will take help of these three sets to prove all the properties which are given, all the four properties. Okay, now we will prove the following properties of sets with the help of these sets. The first one is commutative property of union of sets. Yes, I know you people remember that we have done commutative property of addition and commutative property of multiplication. What was that? Who can tell me? Yes, exactly. In commutative property of addition, if we will write 4 plus 5, it is same as 9. And if we will write 5 plus 4, it is also equals to 9. So this is commutative property. And in multiplication, if we will do 3 multiplied by 2, the answer is 6. And if we will do 2 multiplied by 3, the answer is also 6. So this is commutative property of multiplication. Here in sets also, we can do same thing, or we can find same thing or same property, commutative property of union of sets. If we will find A union B, or we will find B union A, these are same things. As if we will take these two sets, set A is ABD and set B is BCE. So A union B is ABCDE and B union A is also ABCDE. So both the sets are equal. So this is called commutative property of union of sets, and we can prove it like left hand side is equals to right hand side. This is left hand side and this is right hand side, and both are same. Now commutative property of intersection of sets. In the same way, when we will find common elements of both the sets, A intersection B is equals to B intersection A. Set A is ABD, set B is BCE. So A intersection B, the common element is B, and in B intersection A, the common element is B. So it means left hand side is equals to right hand side. So it is proved that the property is correct. Now, associative property of union of sets. Now, do you remember we did associative property of numbers also in addition, in multiplication? Yes, same way. Like suppose if we have three numbers and we will do 2 multiplied by 3 first, then multiplied by 4. So answer will be same as if we will do 3 multiplied by 4 first, then we will multiply that by 2. So answer will come same. In the same way, when we will do union, the answer will be same. Like A union B and then union C, the answer is A, B, C, D, E, F, G. And if we will do B union C first, then union A, the answer will be same. So we can say left hand side is equals to right hand side. So the property is proved, that associative property of union of sets is a correct property. Yes, it happens, it exists. Now associative property of intersection of sets. Again same thing. If we will find common elements of A and B and then common of C and A and B, the answer will be B. And if we will find B intersection C first and then with the answer we will find A intersection, so the answer will come same, the B. So it means again left hand side is equals to right hand side. So the property is proved. The associative property of intersection of sets is a correct property. It happens, it exists in the sets. Now summary of today's lesson. What we learned today? Yes, we did operation on sets as union, intersection, difference and complement of sets. We did Venn diagrams and we learned properties of sets. I hope you enjoyed today's lesson and you can implement your learning in your written assignments. Task number 1, question number 3 to 5, exercise 1, page 17 of new countdown 7. Task number 2 is question number 6, exercise 1, page 17 of new countdown 7. Task number 3, question number 7 to 9, exercise 1, page 18 of new countdown 7. And task number 4 is question number 10 to 12, exercise 1, page 18 of new countdown 7. I hope you enjoyed today's lesson. Allah Hafiz and keep practicing.